Hello, 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 everybody, and welcome back. Root Beer here with question number 4, the very last question on the Galois paper. That's the grade 10 written paper from 2017. So I've got my pen ready. Hopefully you've got yours. Let's take a look at this question. It should be pretty challenging. It is the last question on the Galois. A Keller triangle, or a Kohler. I always have trouble with the OEs. I think it's a romanization of the German O with the double dot, the umlaut on it. I'm just going to say Keller. But a Keller triangle is an m by n rectangle where m and n are integers, with m and n both greater than 3. Bet it has something to do with this picture here. Has lines drawn parallel to its sides that divide it into 1 by 1 squares. Okay. And the 1 by 1 squares along its side are unshaded, and the 1 by 1 squares that do not touch the side are shaded, just like this picture here, which happens to be a Keller rectangle with m is 8 and n is 6. Okay, so it's a 6 by 8 rectangle, and the inside area is shaded. For a given Keller rectangle, let R be the ratio of the shaded area to the unshaded area. Okay, so in particular, we do need to have that order proper, shaded to unshaded. Okay, if we mess that up, we're going to probably have some problems. Well, we have a light bulb and 2 written parts here. Light bulb, part A, determine the value of R for a Keller rectangle with m is 14 and n is 10. Okay. Now, just looking ahead, I'm just out of the corner of my eye, I'm catching R is being written as a fraction. They say it's a ratio. This is something that sometimes happens. Ratio, rational number, they have the same root. It looks like they're writing R as fractions later on, so that's what I'm going to do, rather than do something like, oh, it's a 5 to 7 ratio. That's what I think of when I think ratio, but it looks like they're doing fractions. So we would do R is 5 over 7. So just very quickly, we remember R is the number of shaded over unshaded. We got to set up our ratio properly. And I'll double check that is correct. Shaded to unshaded. Okay. So determine the value of R for a Keller rectangle with m is 14 and n is 10. Okay. So, I mean, you could actually draw the whole thing out. I'm not going to bother with that. I'm just going to make some observations. So everything in here is shaded. Well, so notice the shaded squares form a rectangle. Not only is it a rectangle, but it is an m minus 2, n minus 2 rectangle. So this has a total of m minus 2 times n minus 2 shaded squares. And what does this do? This leaves, there's a total of mn squares minus m minus 2, n minus 2 unshaded squares. Well, we can simplify this expression a little bit, I think. Mn minus, and this is m times n, use FOIL, 2m minus 2n plus 4. So those are going to cancel, and then we're going to be left with 2m plus 2n, and we've counted the corners twice, so we can subtract off the 4 corners. Okay. So not only can we answer the question, but now if anyone asks us any r, and they give us the m and n, we can answer the question. It'll be r is mn, or m minus 2, n minus 2 over 2m, 2n minus 4. So for A, r is 14 minus 2, 10 minus 2, over 2 times 14 plus 2 times 10 minus 4. That's going to be 12 times 8 over 28 plus 20 minus 4. It's going to be 96 over 44. And we'll flip the page and divide both top and bottom by 4. So 96, what did I say, divide by 4, right, is 24. And 44 divided by 4 is 11. So that'd be our final answer for A. You can just put 24 over 11 in the box. I like this whole observation. If I screwed up my subtraction or something like that, I can still get part marks for applying my formula properly. But now I've made a more general observation. R is this expression. I just need M and N. And that more directly relates to these Keller rectangles. Okay? So I think we're in a better shape going forward with B and C. Alright, so B. And this is one where we have to write everything up. Determine all possible positive integer values of U for which there exists a Keller rectangle with n equals 4 and R is U over 77. Okay. So, from our observation in A, we'll have U over 77 is R, but that's M minus 2, N minus 2, 2M plus 2N minus 4. Okay. But N is 4, so this will be M minus 2 times 2 over 2M plus 8 minus 4. U is equal to 77 is 2M minus 4 over 2M plus 4. Aha! Okay. Now, what exactly do we want? We want determine all possible values of U. All right. What can we do? What can we do? The fact that these two numbers differ by 8 makes me think that 2m plus 4 will have to sort of be equal to 77, but maybe a multiple of 77. Anyway, let's multiply everything out. You know, no sense in having numbers on the bottom when we can bring everything to the top. So we'll have U times 4 plus 2mu is 154m minus 28 times 11, so that's 2828, 80, carry the 1, so 308. All right. Not exactly seeing anything obvious to do here. Yeah, because I have one equation and two unknowns, and that makes sense because we'll probably have multiple values for you. I'm just wondering, do I keep rearranging this, or is something else, is something better going to come along? There's no way to get rid of these m's, and I've got u on one side. So maybe instead we'll write u is equal to 77 2m minus 4 over 2m plus 4. Now I can divide top and bottom by 2. I'll get 77 m minus 2 over m plus 2. So that's a little helpful. Now, so u is an integer. So we need m plus 2 to divide 77 times m minus 2. Okay, what can we do? What can we do? Well, let's see, I can rewrite this as 77 m minus 2 plus 4 times 77 minus 4 times 77. And now I can combine these two to be 77 m minus 2 plus 4, or really say 77 m plus 2 minus 4 times 77, which I think I just said was 308. Now m plus 2 divides this part, therefore m plus 2 must divide the other part, 308. Now we can start getting values for m. So m plus 2 is a factor of 308. Well, what are the factors of 308? We could have, so I'll say factor, and then I'll say what m is, and that'll be 2 less than the factor. So we can have 1, 2, 4, 7, 11. Let's see, this is 2 to the 2 times 7 times 11. So we should get 2 plus 1, 3 times 2 times 2. So we should get 12 factors here. We'll put a 14. 22. 28. I know 308 is down here at the end. 154. 44 is somewhere in there, so 44. 77. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I've got them all. So m would be -1 or 0. None of that's good. 2 is fine. Oh no, 2 isn't fine because m has to be greater than or equal to 3. But m could be 5, or 9, or 12, or 20, or 26, or 42, or 75, or 152, or 306. All of those are fine. And what is the u that we get? Right, u, we need to remember, is... So u is going to be this expression here divided by the m plus 2. So that'll be 77 minus 308 over m plus 2. So that'll be 77 plus 308 over 7, which will be 44. So 77 plus 44. 121. 77 plus 108 over 11 is 77 plus 28. Sorry, 77 plus, I hit 7 plus 28. That'll be 105. We can keep going. Did they ask for the values of u or how many values of u? Determine all possible values of u. Okay, so we do have to work all these out. This one down here at the end is 77 over 1, or 77 plus 1, so that's 78. That gives us 2. This one's 4, just sort of the opposite end, pairing these things up. So 77 plus 4, 81. 77 plus 7 is 84. 77 plus 11 is 88. 77 plus 22 is 99. 77 plus 14 is 87 plus 4, so 91. So, of the 12 factors, only 9 of them give us values for m that work, and I think that's key. Because, I mean, we could have gotten other u values here, but we would have had terrible m values to work with. But 1, 2, 3, 4, 5, 6, 7, 8, 9. So I might say, therefore, u can be 78, 79, 81, 84, 88, 91, 99, 105, or 121. all 9 values. There they are. I bet this was definitely worth a mark, is crossing some of these off. Okay. So there we go. And, I mean, if we wanted to, we could pick one at random. Can we really get U is 91? Well, what M would we need? We'd need to have a 20 by 4. So that would give us 91 over 77. So 20 by 4, that would be 2M minus 4. So that would be 40 minus 4 over 40 plus 4. Something's wrong, because U should always be less than. Ah, there it is. Need a minus sign. Yeah, that's good. This shows you that checking really does work. So that'd be 36 over 44. And so that wouldn't be 91, but we'll find out what that is in just a moment. So now it's subtracting. So this is 76, this is 75, this is 73, 44 goes with 7, so that'll be 70, 28 and 11, so that'll be 66, 22 and 14, so that'll be 67 minus 4, so 63, 55, 11 goes with 28. Hold on. So 7 would go with, so 4 would go with 77. But that would be 0, and that wouldn't be a positive U. 7 goes with 44, so that would be 33, and that's the last one there. 11 goes with 28, and so that'd be 57 minus 8, or 49. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we got them all. And so in this case, it's 63 that we've got here. And that makes more sense. So double checking really worked out. 49, 55, 63, 66, 70, 73, 75, or 76. Okay, so there's our final answer, and this was just us doing a little check. And thank goodness we did. Or we would have gotten B part wrong, horribly wrong. Probably would have only lost a mark, maybe 2. Because it's just a simple arithmetic error we did there. Okay, and we could check the other ones, but we don't have time. We only have 75 minutes to do this, so let's move on to C part. Determine all prime numbers P, for which there are exactly 17 positive integer values of U for Keller rectangles with n is 10 and r is U over P squared. Whoa, okay. Okay. So, same sort of setup as the last one. Still solving for these U's here. And this is still m minus 2, n minus 2 over 2m plus 2n minus 4. But now we've got m minus 2 times 8 over 2m plus 10 minus 4. So that's going to be 8m minus 16 over 2m plus 6. That is a very different expression. Okay. And what did we do before? So we said U has got to be P squared over 8m times 8m minus 16 all over 2m plus 6. U is positive integer. So 2m plus 6 divides P squared 8m minus 16. Alright, so what did we do before? So 2m plus 6 has got to divide P squared 8m minus 16. Well, that's going to be, so 8m, let's multiply this by 4. So P squared 4 2m plus 6. And that's going to give us 8m plus 24. We need to get negative 16, so 24 minus negative 16 is a total of 40. So we'll say minus 40. Yeah, okay. Which is p squared 4 times 2m plus 6 minus 40p squared. Therefore, 2m plus 6 needs to divide 40p squared. And now we once again just have a relationship between m and some number here. All right. So 2m plus 6 is a factor of 40p squared. Now, I did it very quickly before, but we'll talk about this again. Put 2 to the 3 p squared times 5. Now, if p isn't 2 or 5, which I don't think it is, but we'll have to do separate cases for that, there's going to be 3 plus 1, 2 plus 1, and it's 5 to the 1, so times 1 plus 1, or 4 times 3 times 2, which is a total of 24 factors. But we don't want 24 factors, we want 17 factors. Well, just like before, we threw 3 of them out because the m values were too small. I think we can work out which m's we can get rid of. So, let's see here. Now, suppose p is equal to... I'm going to do my special cases first, and then we're going to get into it. So suppose p is equal to 2. Well, then 2m plus 6 is a factor of 2 to the 5 times 5, which has 5 plus 1 times 1 plus 1, 12 factors. And this is not enough. I mean, even if we got rid of things, even if we didn't get rid of things, even if all factors gave us valid m's, which they won't, this would be not enough to get 17 factors. So p is not equal to 2. I suspect something similar will happen if p is equal to 5. So then 2m plus 6 is a factor of 2 cubed, 5 cubed, which has 3 plus 1 times 3 plus 1, 16 factors. Again, not enough. So p is not equal to 5. Okay, so now this is the correct prime factorization. So p is not equal to 2 or 5. So 40p squared has prime factorization of 2 to the 2 cubed p squared, 5 to the 1. The p probably should be further out, but I like having the decreasing order here. And has 3 plus 1, 2 plus 1, 1 plus 1, 24 factors. Okay. Now, depending on our choices of p, we'll be removing some of those. So, what are the factors? So, we must have m greater than or equal to 3. So then 2m is greater than or equal to 6. So 2m plus 6 is greater than or equal to 12. So we need to have exactly 17 factors need to be greater than or equal to 12. For whatever p give us that, we're set. We're done. Nothing else to worry about. Okay. So what sort of factors do we have? Well, we've got 1, 2, 4, 5, 8. These are all factors that are less than 12. 2 times 5, 10. So that's 1, 2, 3, 4, 5, 6. So we got 6 factors less than 12 automatically. And we can only allow 1 more, unless I've missed something. Got to be very careful that we didn't. 2 times 5, no, that's it. So we can only allow 1 more such factor. So none of these factors involve. So the other factors that we can make without p are 20 and 40. So that's 8 factors in total. So all other factors have p in them. Okay, p or p squared, doesn't matter which. These other factors can be ordered. So we'll have p, we'll have 2p, we'll have 4p, we'll have 5p, we'll have 8p, we'll have 10p. Okay. Now p is not equal to, well, they can't be completely ordered, but we'll have 20p, we'll have 40p, and then we'll have the same thing but with p squared. And 5p squared, 8p squared, 10p squared, 20p squared, and finally 40p squared, which is the largest of everything. Now, I don't know if 10p is, or if 20p is bigger than 5p squared. I really don't. But I'll tell you what I do know. We need to have exactly the smallest one of these be less than 12, and then the next smallest be greater than 12. So p is not equal to 2. So we know 2p is less than p squared. So to have 17 factors that work, and give us the Keller rectangles with the ratio we want, we must have p be less than 12 and 2p be greater than or equal to 12. That will ensure everything, because that will make p squared bigger than 12, and everything else in this list will be bigger than or equal to 12. But we do need one factor that's still less than 12. So p is not 2 or 5. So p could be 3, 7, 11. Can't be 13. 13 is now too big. It's over 12. But that would make 2p equal to 6, 14, 22. Well, 6 is too small. So 7 works and 11 works. Actually there's not a whole lot else to say. P is 7 or 11. There we go. I don't know if they realized this, but 7 times 11 is the 77 we get down here. I think it's just a coincidence because of this p squared stuff. But yeah, there's going to be 17 positive integer values for u. Each factor gives us a different value of u. Maybe that's something worth mentioning at some point. But we had 6, 1, 2, 4, 5, 8, and 10 that came for free from 40p squared that are less than 12. And we need to be greater than or equal to 12 because they tell us m is greater than or equal to 6. Sorry, m is greater than or equal to 3. So 2m is greater than or equal to 6. So 2m plus 6 is greater than or equal to 12. So 6 of them are already out. We can only lose one more factor of the total 24 factors. Okay, then the 17 other ones will be greater than or equal to 12, so we just need p, the smallest of those other factors, to be less than 12, but as we noted, 2p and p squared, they both have to be greater than or equal to 12, so we just need 2p greater than or equal to 12, and that gives us a 7 and 11. Very nice. All right, so that does C, and we wrote everything, we justified everything, and that finishes off our paper, our 2017 paper. So join me for more written contests and more multiple choice contests if that's something you're interested in. Whatever's coming up, I've got videos for all the CEMC papers, well, all different types, not all the ones that have been written, because I'm still missing some years. But yeah, join me for more of those in the future, and yeah, have yourselves a wonderful day. Thank you so much for watching. Feel free to like or subscribe to be kept up to date. But no matter what, keep on doing math and join me for more math videos in the future.